Thanks everyone. Yes, I'll be telling you a bit about the energy savings scheme. I thought it was a bit hard to figure out, what the level of knowledge is and whether I should be talking more about the mechanism that sits behind the energy savings scheme or what participation really looks like. So we'll really look, hopefully, in equal measures at both. So we'll look at what an ESCI is. That is really what people are calling the financial instrument that the energy savings scheme centers on. So what is an ESCI? We'll look at what the demand for ESCIs, how that is created, so that where does the demand for these certificates come from? What provides the supply of these certificates? We'll look at the type of projects that can create these energy saving certificates. The methods that we use to calculate those certificates, and then the bit of the decision making around choosing the right method, and of course participation in it, and there will be room for some questions if we have some time. We'll look at a couple of case studies as well. So an energy saving certificate or an ESCI is really representative of 1 megawatt hour notional megawatt hour of energy savings. And notional basically means we calculate the energy savings of a project, then there is a certificate conversion factor that we apply, and it turns that megawatt hour into a notional megawatt hour of energy savings. The certificates are tied in the energy savings scheme to energy savings. There's quite a few people who will tell you it is tied to greenhouse gas emissions, but that's not really how it is. It may have started that way, but today it is all about the energy savings. The energy savings can be calculated for projects that save electricity, that save gas, and we'll look at that a bit in a moment. For every certificate that we create and therefore register, we have to pay the scheme administrator 86 cents. So we'll look a bit more at the rewards that come out of it later, but 86 cents per certificate is a cost that we bear in the creation of those. And then the value of the certificate, so the money that we sell them for, is driven by supply and demand, and like any market, really market sentiment. So this graph is really the only reason why it's there, is just to show the certificate market and where pricing has been. So there's moments of high demand when a year finishes and the people in it need to surrender a number of certificates, and all of a sudden they start buying, so demand goes up. Prices of certificates fluctuate. At the moment, we can sell every certificate or every notional megawatt hour of energy savings in that sense for about $19. But let's have a look at demand for ESCI. So the primary market for energy saving certificates is out of New South Wales legislation. So there's energy savings targets for the scheme participants. They're the mandatory scheme participants, which is basically electricity retailers, direct suppliers, and then the market customers, so the people just using electricity. The retailers and direct suppliers, they have to buy a percentage of their electricity sales in certificates. So they have to buy a certain amount of energy savings out of the market, and for every calendar year that target has gone up. I don't know if you can see it on the screen over there, but at the moment we're at 8.5%, which at the moment that is what it will be going like until the end of the energy savings scheme of 2025. So every year retailers and direct suppliers need to buy 8.5% of the electricity sales in megawatt hours in equivalent energy saving certificates. They can choose not to and pay a penalty. The penalty is set at the moment it's about $28 per notional megawatt hour. So if they fail to buy a megawatt hour worth of energy saving certificates, they have to pay a penalty for that, and it's about $9 or $10 above what the certificate would cost. So there's an incentive there for the retailers and the direct suppliers to buy these energy saving certificates. They can recover the cost of buying those certificates from the customers. So most people on their electricity bill, especially if you are a contestable customer and it's all specified in the bill, there's a line item in there that says New South Wales Energy Savings Scheme. So all the market customers are contributing to the energy savings scheme. Penalties cannot be recovered, so that's another incentive in that way. There's a secondary market for these certificates because people, like in the stock market, they commit to futures. So they commit to selling a parcel of certificates in the future, and if they fail to accumulate or accrue those certificates, they'll have to go out and buy those certificates from others. And then there's traders and brokers sitting in between who seek to make a little bit of money on that sale. So the demand is legislated. The retailers and suppliers, direct suppliers, and direct means it's not the primary electricity generators. It is really like a solar installation of a certain size that is selling electricity directly to a consumer. The supply of ESCI, so these energy saving certificates can be created by accredited certificate providers, and it can be created only by them. The ESCI represents energy savings, so certificates are calculated based on energy savings, so someone must be saving energy for those certificates to be calculated. The energy saver would typically be the purchaser of the energy efficient equipment, but it can also be a person who is nominated by the person who purchased that equipment, because it has to be an ACP. The energy saver could create the certificates themselves, so a business installs efficient equipment, they could create certificates themselves, but they would have to become accredited, and that is quite an involved process. So this is where that nomination comes into play. So there's voluntary participants in the scheme like ourselves. We have become accredited to create these certificates for different projects, and then a business can come to us, or a household, but a business can come to us and say, hey, I'm going to install a new air compressor, a new chiller, a new whatever it is. There's going to be energy savings. Can you create these certificates on our behalf? And so that's really where how that would work. So as the ACP, we calculate the savings, sell those certificates to the people who need them. So then we get a pool of money, and that pool of money then we pay most of that back to the original energy saver, the person who was actually saving that money, that energy, and we retain our fees. There's a lot of eligible activities. In the scheme they call them RESAs, recognized energy savings activities, and it may include modification of existing plant. It can be the replacement of existing plant, but it can also be the installation of new plant where there was none before. It could even include removing equipment that is no longer needed, fuel switching, so from gas to electricity or vice versa, and also some generation projects are eligible. There are some conditional things around that. Projects that can claim, under the renewable energy target, for example, are not eligible. So there are some qualifiers there. It has to be in the ESS jurisdiction, which really is New South Wales, but there are some provisions there that other jurisdictions might join, like the ACT. A big thing is that it cannot reduce service levels, so you can't, half your office space or half your data center and claim that as energy savings. It really has to be an efficiency, not reduced energy as the result of reduced service. That is not the purpose of the scheme. The ACP, who is nominated to create the certificates, has to be nominated before the project is implemented. So the implementation can start, but it cannot finish before the ACP is nominated. And then there's a few other eligibility criteria, but it depends a little bit on the method that is used, and we'll look at that a bit more. As we get to the methods, things might become a little bit more convoluted, because there's just so many. Not many that are really used effectively, but there are many, and a lot of different reasons why you could use different methods. So we look at three main categories: the deemed energy savings method, which has a number of sub-methods. Then there's the project impact assessment method with measurement and verification, and then there's the immediate baseline method. Under the deemed method, there's sale of new appliances, right? So you can go and buy a new washer, dryer, fridge, TV, and if it has a star rating that is above the minimum star rating that is available, then you could create a small reward for that. The commercial lighting formula, which is by far the most popular one, it has been creating more than 90% of the certificates, and with some other method it has come down, and we're probably looking at about 70% of the certificates that are created out of commercial lighting upgrades. So it could be anything from car park fluorescent lighting upgrades to high bay lighting upgrades in warehouses and factories. Public lighting has its own method, so where lighting is owned by the Roads and Maritime Services, for example, or where the councils own the lights. There's the home energy efficiency method, so relatively small scale. It's really a volumes game, where downlights go in and equipment from other categories, shower heads, pool pumps, etc. High efficiency appliances for businesses. It's really just a simpler method to create rewards for equipment upgrades in businesses where the savings are perhaps a bit small, so a bit too small to do an elaborate measurement and verification exercise, and we'll look at that in a moment. The deemed energy savings methods all are quite prescriptive, so there's only a number of clauses you can do for pool pumps, washers, and there's a very strict calculation method to how many certificates you could create for a washer, for example. The PIAM&V, or the Project Impact Assessment method, is non-specific. You can really create certificates for just about any upgrade as long as you can verify the savings that these projects establish. The same is true for the metered baseline method. It's also non-specific. It has a number of sub-methods. We'll touch on that in a moment. So one of the points of discussion is really the concept of deeming and forward creation. So a number of the methods allow us to calculate energy savings, let's say for 1 year, and then forward create this, so basically bring savings forward. So the energy savings scheme might say you've installed a new chiller, that chiller is going to last 10 years, so those savings, those first year savings, are realistically going to replicate in the second, in the third, in the fourth, etc., until typically 10 years ahead. There are then some decay factors that we have to account for. Savings typically are not the same in the second year, perhaps, because savings might drift, right? Sensors might drift, etc. But that's an important concept, and we'll get to that later. But not all the methods allow you to do that. Some of the methods you'll have to verify the savings every year, create the certificates, sell them, get your money, do it again the year after, do it again the year after. Whereas then there's methods that allow you to do it for 10 years straight off the bat. Another graph which really I put in there just to indicate, so there are different methods. The dark green is the commercial lighting formula, so consistent with what I was just saying, that lighting creates by far the most certificates in the scheme. And then there's other methods that some months the project impact assessment method might create the next largest number, but then other months it might be a different method. Commercial lighting is still quite dominant. Now this gets a little bit wordy perhaps, but really just a couple of examples. For example, in the commercial lighting method, if you had an existing scenario where you had 100 400 watt mercury lamps, and you were replacing that with 80 because you might need less, for the same light output or same light levels, then you would obviously drop your electric load a fair bit. And the energy savings scheme prescribes for what type of space type, what type of building type, how many hours of operation that really has. So for an industrial environment, we get 5,000 hours, for example. Then there's the asset lifetime. These things have changed quite recently, but in the industrial areas, we get 11.7 years of lifetime for an asset in that environment, or for the lighting in that environment. So a calculation then shows that if you take the difference in the electric load from your previous lights and then your new lights, and they run 5,000 hours per year, and you can bring the savings for 11.7 years forward. There's 1,590 megawatt hours of savings over those 11.7 years that we could create certificates for. And at the start of the Prezzo, I was touching on the certificate conversion factor. So now we change the megawatt hours into notional megawatt hours by the certificate conversion factor. Well, look, the wash up of it is there's about almost 1,700 energy saving certificates that we could create for a project like this. At $19, which is where the certificate market is today, that would mean $32,000 in reward, of which we might take a percentage and then pay the rest to the end user. And it really incentivizes that project. It really drives that change, and that's really in lighting where the discussion is at the moment. How much change is it still driving in lighting? People are choosing LED one way or another. I think the takeaway before we move on is a lot of inputs come from the rule. It certainly matters what lights you have in your parameters before the upgrade occurs. And then there's inputs, for example, a mercury lamp. The rule even prescribes what wattage we have to use, what the losses are, etc. But it gives you a good idea of how the savings would be calculated. Then there is high efficiency appliances. This particular example is for businesses, but really the concept is the same whether it's a home energy efficiency retrofit or high efficiency appliances for business. Sale of new appliances, the rule prescribes what you can create for these appliances. So what I've tried to indicate here is that from the public register, the greenhouse register, and where the minimum energy performance standards are recorded, I take a particular chiller. So a customer comes to us and says, hey, we're going to install a new chiller. I look that up on the registry and I find some information on that chiller. And it says, for example, the cooling capacity, the coefficient of performance, and then on the very far end, the integrated part load value. Now what it means is otherwise unimportant, but the main thing is then the Energy Savings Scheme rule then prescribes for that capacity with that integrated part load value, you can use this number of operating hours, you can bring savings for 10 years forward, and so what this ends up with is almost 600 certificates for that particular chiller. So this is a scenario where there was nothing before. It is just because the customer chose a chiller that exceeds the efficiency of what he could have also bought, that gives him access to $11,000 in funding. And $11,000 it will be slightly less because we'll be taking a fee out of that. Probably the more complex method, I've tried to keep it quite short for exactly that reason, are the PIAM&V method in particular, and also the metered baseline method. What we do there is we correlate energy consumption with what would be a key driver of energy consumption. So in an HVAC, in a heating, ventilation, and air conditioning system, that could be, that would be weather and perhaps a bit of occupancy. In a compressed air system in a factory, it could be production. How many tons of product you're producing, and we correlate that energy consumption with that what we call independent variable. And what you will find is that there are pretty strong relationships there that allow you to predict energy consumption based on that variable. So if you see a day coming where you have so many tons of production, you can predict quite accurately what your energy consumption is going to be. So that's what we do. We correlate an independent variable with energy consumption. Then we look at the performance before. So how did electricity respond to that independent variable before the upgrade, and how does it respond after the upgrade? So for, let's say, in an HVAC system, if you had a 30-degree day before the upgrade, your chiller may have used X number of kilowatt hours, but after the upgrade, at the same temperature, so the same load as such, your chiller used a lot less. So it becomes a pretty accurate way of establishing whether there was a real energy efficiency there. Based on those energy savings, then we calculate the energy saving certificates. And this particular example, there's a case study at the end of it. This particular example is the Art Gallery of New South Wales. So they installed 2 out of 3 chillers were replaced. with the latest magnetic bearing oil-free chillers with much better part load performance. And so the blue indicates what the relationship between consumption and wet bulb temperature was before the upgrade, and the red indicates what the relationship was after the upgrade. So it has come down in amplitude, and also the slope is just a little bit less steep. So the PIAM&V and the immediate baseline method, they can both do very similar things. There were a few items that I wanted to just highlight in terms of what the differences are. So the rewards in both cases are based on energy savings. The immediate baseline method can be quite simple. A good example is a neighbors baseline method. So commercial buildings, net lettable area over 1,000 square meters, they need to be neighbors rated, or they need to have a building disclosure statement, and part of that might be a neighbors rating. So 1 year a building gets a neighbors rating certificate, the year after it gets a neighbors rating certificate, and that difference in star rating equates to a certain number of kilowatt hours difference, and for that number of kilowatt hours we can create energy saving certificates. The PIAM&V method is certainly more complex, like what we just looked at with the regression analysis, but it can bring future savings forward. So it is really a very robust measurement and verification principles that it adheres to. It applies accuracy factors in terms of with how much certainty we can predict energy consumption or savings for that matter, and then project these energy savings out for 10 years. And so that way we can, for also large upgrades, we can bring the savings forward and create all those certificates at once. The immediate baseline method can't do that. Immediate baseline method is really measuring performance before, then measure it after, create certificates. Next period, measure it again, create certificates again, and the next period again. So you create smaller rewards spaced out apart, over time for the life of the project. So the PIAM&V is very inflexible when it comes to a changing environment, and a good example might be a data center where the IT load is ever growing. So if the IT load grows, and you might find that per kilowatt of IT, you might get that you save energy. You might use less kilowatt hours of energy per unit of IT after the upgrade. So you've become more productive as such. But in absolute terms, your energy consumption may have gone up because your IT load has gone up. And the PIAM&V is very inflexible in that way. The immediate baseline method can handle that to a certain degree. The immediate baseline method, because you do it period after period, what some people value in that is that you have a level of continuous tuning. So you don't set and forget and savings drift. You've already created all your certificates, you already got all your reward. But really in year 5, an important point is, of course, the certificates are on top of the energy savings that you're establishing and the cost savings that go with that. So if in year 5, all the variable speed drives have been, changed, and some equipment is not running as efficiently as it once did, then you're not having your energy savings anymore in year 5, 6, 7, and so forth. So the immediate baseline method, because you go period after period, there is really an incentive there to make sure that year after year all your equipment is still running the way it was intended. So there's no decay factors in the immediate baseline method either. So because you create year on year, you create the actual savings. You don't discount the savings based on a model where you say that the savings won't persist. On the other hand, the measurement and verification method also has a way to top up. So in latter years, we can say, let's have another look at what has happened, and if the savings exceeded the first year's savings, or what we created certificates for in the first place, then we could create those certificates once again. So which method is really best to apply is depending on a lot of factors. But for example, whether you're looking for an efficiency in a home or in a business, whether you're installing a new piece of equipment that was nothing there before, or is there an upgrade? Do you want to deem? Do you want to get that money now up front, or do you want to get paid later, maybe spaced out over time? That set and forget principle. The For commercial lighting upgrades, generally we use that method that dominates the scheme, commercial lighting energy savings formula. There are some scenarios where that might, where the PIAM&V method might be better. An example could be that factory that I was talking about. Every factory would get 5,000 hours. Now, if you have a factory that runs, 8,500 hours, then you won't quite get the certificates for all the energy savings that you are establishing. You're running 3,500 hours more than what the scheme allows you to create for. So if you then do a PIAM&V creation, you create on the actual hours that you're operating, which can make a big difference in that case. Any appliances and small equipment, especially where the savings are expected to be relatively small, realistically it would be a volumes game. You use the sale of new appliances, the home energy efficiency retrofit scheme, or the high efficiency appliances method, and there's a lot of abbreviations and acronyms and all that involved. And for everything else, really, we can use the PIAM&V or the immediate baseline method. So for participation, really, of course, you can become an ACP yourself if you had a project. If it's a large project, that might well be worth it. But for most people, it is. They go to there's a website address in the bottom there. So that's the Energy Savings Scheme, the ESS website. There's you can look for your accredited certificate providers. You can filter them by the sort of technologies that they're accredited for, and you could have a chat and see if they can calculate what the energy savings might be. Maybe there's a consultant involved who has already done some calculations on that, and very quickly the ACPs can give you an idea of the reward that you might get out of the energy savings certificates. Importantly, again, nomination of that ACP has to happen before the implementation is done. If we just consider for a moment the measurement and verification method, and I might just have a look at this one quickly. So that graph with the blue, the blue scatter plot over there, that's a baseline period. So that's before the upgrade. Hopefully, the site-wide data, so the NMI data, the electricity bills, etc., they provide us with enough data to make a model like that. If the consumption that we are seeking to reduce and seek to create certificates for is large enough as a proportion of the whole site, well, then we might well be able to do that. We might just be able to make a model like that using electricity invoices. It becomes a bit harder when you're replacing a compressor in a large factory where the consumption is so much higher. The compressor is only 5% of total site consumption. Then it might have to be sub-metered. If you're going to sub-meter it, well, a lot of customers say, I'm going to replace my compressor tomorrow. There's not much room there to sub-meter. So, I hope that point makes sense, and that's really why I'm saying, ideally, you talk to an ACP long before an upgrade happens, because if sub-metering is required, especially in HVAC and heating, ventilation, and air conditioning upgrades, we might just have to measure for quite some time before we can build an energy model that meets all the requirements of the energy savings scheme. So far, we have been able to build most models using utility data, so using NMI data or sub-facility data. Sometimes an NMI, like the main electricity meter, is built up of multiple meters, so we might be able to zoom in. I was going to get to the questions, but I thought before we do that, we might just run over a couple of case studies. So that's a lighting upgrade at the Hilton in Sydney. I won't labor on it, but 233 megawatt hours in savings. So that that is associated with some serious energy cost savings as well. And the $23,000 in ESCI funding offset that project cost of that lighting upgrade quite significantly. Lighting has really gotten to the point now where for a lot of lighting suppliers it is difficult to sell lights if they don't have products that have been approved for use under the energy savings scheme. So it's really matured in that sense. So the art gallery, which I touched on, so they replaced 2 out of 3 chillers. So there was funding of over $100,000 in energy savings certificates because the savings were quite significant, more than 1,200 megawatt hours in savings per year. Yeah, so we're talking about a very reasonable percentage of the total project cost that was funded through these energy savings certificates, and in fact in this case it wasn't funded as such. It's a reward that comes back on the back of the energy savings. So the project is done, paid for, the savings are established, rewards are paid, and now they're spending some of that money on further energy efficiency upgrades, for which we will be able to create more certificates. Car park exhaust, so car park ventilation just in general, so going from a full ventilation car park or a car park that maybe has a timer that runs at 3 hours in the morning, 3 hours in the evening, install a pollution control system, and based on CO levels, the fans ramp up and down with frequency control. And the savings that result, we can establish that and create certificates for that. So again, the project cost is offset that way. A little bit of a specialty for us is that we've been able to create certificates on a number of vertical transportation projects. So passenger lifts and also an escalator. So I mean. Same thing. So an old lift, we sub-meter it for a little while, and then they replace the lifts with the latest technology, and the savings that result, we can create these certificates on. In the context of the cost of a lift upgrade, the reward out of this was relatively small, but not nothing. $13,000, which is not bad.